Module 1. Question number 1, A. Explain classification of big data with a diagram. Big data is classified into 3 types. 1. Structured data. 2. Semi-structured data. 3. Unstructured data. 1. Structured data. Structured data is organized in rows and columns. It is easy to store and process using relational databases. Example, bank records, Excel sheets. 2. Semi-structured data. Semi-structured data does not have a fixed table format but contains tags and markers. Example, XML, JSON, emails. 3. Unstructured data. Unstructured data has no predefined structure. It is difficult to process using traditional databases. Example, images, videos, audio files, social media posts.
Question number 1, B. Define big data. Explain its characteristics and challenges. Big data. Big data refers to huge volume of data that is generated at high speed and in different formats which cannot be processed using traditional database systems. Characteristics of big data. 1. Volume. Volume refers to the large amount of data generated from different sources such as social media, sensors and websites. 2. Velocity. Velocity refers to the speed at which data is generated, processed and transferred. 3. Variety. Variety refers to different forms of data such as text, images, audio, video and documents. Challenges of big data. 1. Data storage. Storing massive amount of data requires large storage infrastructure. 2. Data security. Protecting sensitive data from unauthorized access is difficult. 3. Data processing. Processing huge amount of data requires high computational power. 4. Data integration. Combining data from multiple sources and formats is complex. 5. Data quality. Maintaining accurate and reliable data is difficult. 6. Data transfer. Transferring large data at high speed requires efficient network systems.
Question number 2, A. What is NoSQL? Explain different types of NoSQL database with example. NoSQL. NoSQL stands for Not Only SQL. It is a non-relational database used to store large volume of structured, semi-structured and unstructured data. Characteristics of NoSQL. 1. Non-relational. NoSQL databases do not use tables and relationships like RDBMS. 2. Distributed. Data is distributed across multiple servers for better performance. 3. No support for ACID properties. Some NoSQL databases do not fully support ACID transactions. 4. No fixed table schema. Schema can be changed dynamically according to application needs. Types of NoSQL database with example. 1. Key-value database. Data is stored in the form of key and value pairs. Example, Amazon S3, Redis. 2. Document-oriented database. Data is stored in the form of documents like JSON or XML. Example, MongoDB, CouchDB. 3. Column-oriented database. Data is stored in columns instead of rows. Example, Cassandra, HBase. 4. Graph database. Data is represented using nodes and relationships. Example, Neo4j. Question number 2, B. Explain shared nothing architecture, CAP theorem and list its advantages. Shared nothing architecture. Shared nothing architecture is a distributed computing architecture in which each node has its own memory and disk storage. No hardware resources are shared between nodes. Types of architecture. 1. Shared memory. Processors share common memory. 2. Shared disk. Processors share common disk storage. 3. Shared nothing. Each processor has independent memory and storage. CAP theorem. CAP theorem states that a distributed database system can provide only two out of the following three properties at the same time. 1. Consistency. All nodes contain the same updated data at the same time. 2. Availability. System remains available and responds to every request. 3. Partition tolerance. System continues to work even when communication failure occurs between nodes. Advantages of shared nothing architecture. 1. High scalability. 2. Better fault tolerance. 3. Faster processing. 4. Low resource contention. 5. Easy expansion of nodes. Module 2. Question number 3a. Difference between RDBMS and Hadoop. RDBMS. Used for structured data. Works on centralized system. Suitable for small data. Vertical scaling. Expensive. Fast for transactional processing. Hadoop. Used for structured, semi-structured and unstructured data. Works on distributed system. Suitable for big data. Horizontal scaling. Cost-effective. Fast for batch processing. 2. Difference between mapper and reducer. Mapper. First phase of MapReduce. Reducer. Final phase of MapReduce. Processes input data. Converts input into key-value pairs. Performs filtering and sorting. Output given to reducer. Processes intermediate data. Aggregates key-value pairs. Produces final output. Generates final result. Question number 3, B. Identify and explain key aspects and components of Hadoop. Hadoop. Hadoop is an open-source framework used for distributed storage and processing of big data across clusters of computers. Key aspects of Hadoop. 1. Open-source software. Hadoop is freely available and can be modified according to user requirements. 2. Framework. It provides a framework for storing and processing large amount of data. 3. Distributed. Data and processing are distributed across multiple nodes. 4. Massive storage. Hadoop can store huge volumes of structured and unstructured data. 5. Faster processing. Parallel processing helps Hadoop process data quickly. Components of Hadoop. 1. HDFS, Hadoop Distributed File System. HDFS is the storage component of Hadoop used to store large files across multiple machines. Features of HDFS. Fault-tolerant. Distributed storage. High scalability. Reliable data access. 2. MapReduce. MapReduce is the processing component of Hadoop used for parallel processing of large datasets. Phases of MapReduce. 1. Map phase. Processes input data into key-value pairs. 2. Shuffle and sort, group similar keys together. 3. Reduce phase, product.
For Quetzales, A. Explain Hadoop Distributed File System, HDFS, with a diagram. HDFS. Hadoop Distributed File System, HDFS, is the storage component of Hadoop used to store very large files across multiple machines in a distributed environment. Key points of HDFS. 1. Distributed file system. 2. Fault-tolerant system. 3. High scalability. 4. Reliable data storage. 5. High throughput access to data. HDFS diamonds. 1. Name node. Master node of HDFS. Stores metadata of files. Manages file system operations. 2. Data node. Slave node of HDFS. Stores actual data blocks. Performs read and write operations. 3. Secondary name node. Maintains checkpoint information. Helps name node in recovery process. Anatomy of file read. 1. Client sends request to name node. 2. Name node provides block locations. 3. Client accesses data node directly. 4. Data is read block by block. Anatomy of file write. 1. Client requests name node to create file. 2. Name node allocates data nodes. 3. Client writes data into blocks. 4. Blocks are stored in data nodes. Replica placement strategy. HDFS stores multiple copies of data blocks. One replica is stored locally and others on different nodes or racks. This improves fault tolerance and availability. Diagram, HDFS architecture. Page 7. 4 Quetzales, B. Identify and explain different phases of the map task and reduce task for the word count problem. Word count problem. The word count problem is used to count the number of occurrences of each word in a given input file using MapReduce. Phases of map task. 1. Record reader. Reads input data from file. Converts input into key value pairs. Example. Key equals line number. Value equals sentence per text line. 2. Mapper phase. Mapper processes input data. Splits sentence into words. Produces intermediate key value pairs. Example. Input. Big data big. Output. Big 1. Data 1. Big 1. 3. Combiner phase. Performs local aggregation. Reduces duplicate intermediate data. Page 8. Example. Big 2. Data 1. 4. Partitioner phase. Distributes intermediate data to reducers based on key values. Ensures same keys go to same reducer. Phases of reduce task. 1. Shuffle and sort. Groups all identical keys together. Sorts intermediate key value pairs. Example. Big 1 1. Data 1. 2. Reducer phase. Reducer adds values of same key. Produces final word count result. Example. Big 2. Data 1. 3. Output format. Final result is written into output file. Stored in HDFS. Diagram, word count using MapReduce. Page 9. Module 3. 5 Quetzales, A. What is CRUD operation in MongoDB? Explain the following commands. 1. Insert command. 2. Update on array. CRUD operation in MongoDB. CRUD stands for create, read, update, delete. 3. Save method. These operations are used to manipulate documents in MongoDB database. 1. Insert command. Insert command is used to add a new document into a collection. Syntax. Example. db.collection.insert1. db.student.insert1. USN: 1BG22CS001. Name: Rahul. Marks: 85. 2. Update on array. Update on array is used to modify elements present inside an array field. Syntax. Example. db.collection.update1. db.student.update1. Name: Rahul. $push, skills, Python. Here, Python is added into the skills array. 3. Save method. Save method is used to insert a new document or update an existing document. Syntax. Example. db.collection.save. db.student.save. _ID 1. Page 10. If the document exists, it updates the document, otherwise, it inserts a new document. Name: Rahul. Marks: 90. 5 Quetzales, B. Determine and explain the characteristics of MongoDB. MongoDB. MongoDB is a NoSQL, document-oriented database used for storing large amounts of data in flexible JSON-like documents. Characteristics of MongoDB.
1. JSON support. MongoDB stores data in BSON format, which is similar to JSON. 2. Unique key. Each document contains a unique _ID field for identification. 3. Dynamic query. MongoDB supports dynamic queries for efficient data retrieval. 4. Storing binary data. MongoDB can store images, audio, video, and other binary files. 5. Replication. MongoDB supports replication to provide data backup and high availability. 6. Sharding. MongoDB uses sharding to distribute large data across multiple servers. 7. Updating information in place. MongoDB can update specific fields in documents without rewriting the complete document. Advantages of MongoDB. 1. High performance. 2. Flexible schema. 3. Easy scalability. 4. Better availability. 5. Handles big data efficiently. 6. Quetzales, A. Write short notes on 1. Aggregate function. 2. MapReduce function. Page 11. 1. Aggregate function. Aggregate function in MongoDB is used to process data records and return computed results. It performs operations such as sum, average, count, minimum and maximum on grouped data. Uses of aggregate function. 1. Data analysis. 2. Grouping records. 3. Calculating totals and averages. 4. Filtering documents. Example. db.customers.aggregate. $match, account type, S. $group, _ID, $cust_ID. Total balance, $sum, $accbal. Explanation. $match filters the records. $group groups documents by customer ID. $sum calculates total account balance. 2. MapReduce function. MapReduce is a data processing model used to process large datasets in MongoDB. It consists of 2 phases. 1. Map function. 2. Reduce function. Map function. Map function processes input documents and generates key value pairs. Example. var map equals function. Emit, this.custID, this.accbal. Reduce function. Reduce function combines values having same key and produces final output. Example. var reduce equals function, key, values. Page 12. Key value pairs reduce final output. Return array.sum, values. Input data. Map. 6. Quetzales, B. Determine and explain creation of database, dropping of database and data types of MongoDB. 1. Creation of database. In MongoDB, database is created using the use command. Syntax. Use database _name. Example. Use MyDB. This command creates a new database named MyDB if it does not already exist. 2. Dropping of database. Dropping database means deleting the database permanently from MongoDB. Syntax. db.drop database. Example. Use MyDB. db.drop database. This command deletes the database along with all collections and documents. 3. Data types in MongoDB. MongoDB supports different data types for storing data. A. Null. Represents a null or empty value. B. Integer. Used to store numerical integer values. C. Boolean. Stores true or false values. D. Timestamp. Used for recording date and time information. E. Minute or max keys. Page 13. Used to compare lowest and highest BSON elements. F. Code. Used to store JavaScript code inside documents. Module 4. 7. Quetzales, A. Define Hive. Explain its main task and features. Hive. Hive is a data warehouse tool built on top of Hadoop used for querying and analyzing large datasets stored in HDFS. Main tasks of Hive.
1. Summarization. Hive is used to summarize large amounts of data and generate reports. 2. Querying. Hive provides HiveQL language to query data similar to SQL. 3. Analysis. Hive is used for data analysis and business intelligence applications. Features of Hive. 1. Similar to SQL. Hive supports HiveQL, which is similar to SQL language. 2. Easy to code. Users with SQL knowledge can easily learn and write Hive queries. 3. Rich data types. Hive supports primitive and complex data types. 4. Supports group by and order by. Hive supports SQL-like operations such as grouping and sorting. 5. Custom types and functions. Hive allows creation of user-defined functions and custom data types. Page 14. Advantages of Hive. 1. Handles large datasets. 2. Easy integration with Hadoop. 3. Suitable for data warehousing. 4. Supports batch processing. 7. Quetzales, B. Analyze Hive architecture with its diagram. Hive architecture. Hive architecture consists of different components that help users query and analyze large datasets stored in Hadoop. Distributed File System, HDFS. Components of Hive architecture. 1. Hive CLI. Hive command line interface is used by users to execute Hive queries. 2. Hive web interface. Provides graphical interface to interact with Hive. 3. Hive server. Hive server accepts requests from clients and processes queries. 4. Driver. Driver manages the query execution process and creates execution plan. 5. Metastore. Metastore stores metadata information such as table names, columns and schema. 6. Job tracker. Job tracker manages MapReduce jobs in Hadoop. 7. Task tracker. Task tracker executes tasks assigned by job tracker. 8. HDFS. HDFS stores large datasets in distributed form. Working of Hive architecture. 1. User submits query through CLI or web interface. 2. Hive server receives the query. 3. Driver parses and compiles the query. 4. Metastore provides metadata information. 5. Job tracker schedules MapReduce jobs. 6. Task tracker executes tasks. 7. Data is stored and retrieved from HDFS. Page 15. Diagram, Hive architecture. 8. Quetzales, A. Define Pig. Explain its features, anatomy and philosophy. Pig. Pig is a platform used for analyzing large datasets in Hadoop using Pig Latin language. Features of Pig. 1. Engine for dataflow. Pig provides dataflow engine for processing large data. 2. Language Pig Latin. Pig uses Pig Latin scripting language, which is simple and easy to learn. 3. Contains operators. Pig supports operators such as filter, join, sort and group. 4. Own functions. Pig supports user-defined functions for customized processing. Anatomy of Pig. 1. Dataflow language. Pig Latin works as a dataflow language for data processing. Page 16. 2. Pipeline shell. Pig provides interactive shell called grunt shell. 3. Pig interpreter and execution engine. Interpreter converts Pig Latin scripts into MapReduce jobs and executes them. Philosophy of Pig. 1. Eat anything. Pig can process structured, semi-structured and unstructured data. 2. Live anywhere. Pig can run on local mode and Hadoop cluster mode. 3. Domestic animals. Pig works closely with Hadoop ecosystem tools. 4. Pig fly. Pig improves performance and simplifies data processing. Diagram, Pig architecture. Pig. Features anatomy philosophy Hadoop. 8. Quetzales, B. Examine identifiers, keywords, data types and operators of Pig with an example. 1. Identifiers in Pig.
Identifiers are names used for relations, fields and variables in Pig Latin. Valid identifiers. A1. Student_data. Sales 2024. Invalid identifiers. 5 sales. @data. Page 17. Student name. 2. Keywords in Pig. Keywords are reserved words having predefined meaning in Pig Latin. Examples of keywords: load, store, filter, group, for each, join. 3. Data types in Pig. Simple data types. 1. Int. 2. Long. 3. Float. 4. Double. 5. Char array. 6. Byte array. Complex data types. 1. Tuple. 2. Bag. 3. Map. 4. Operators in Pig. A. Arithmetic operators. Used for mathematical calculations. Examples: plus. B. Comparison operators. Used to compare values. Examples: equals equals. Equals. Page 18. C. Null operators. Used to check null values. Example: A is null. D. Boolean operators. Examples: and, or, not. Example of Pig script. A equals load student.txt using Pig storage, comma. AS, ID, int, name, char array, marks, int. B equals filter a by marks greater than 50. Store B into output. Explanation. Load reads data from file. Filter selects students with marks greater than 50. Store saves output into HDFS. Page 19. Module 5. 9 Quetzales, A. Analyze Spark SQL and Pandas for data analysis. Spark SQL. Spark SQL is a module of Apache Spark used for processing structured and semi-structured data using SQL queries. It allows users to query data stored in different formats such as JSON, Hive tables and Parquet files. Features of Spark SQL. 1. Fast processing. Spark SQL performs in-memory processing which increases speed. 2. SQL support. Supports SQL queries for structured data analysis. 3. Integration with Hive. Spark SQL can work with Hive tables and HiveQL. 4. DataFrame API. Provides DataFrame abstraction for efficient data manipulation. 5. Supports multiple data sources. Can read data from JSON, CSV, Parquet and databases. Functions of Spark SQL in data analysis. 1. Data querying. 2. Data filtering. 3. Data aggregation. 4. Data transformation. 5. Report generation. Pandas. Pandas is an open-source Python library used for data manipulation and analysis. It provides powerful data structures such as series and data frame. Features of Pandas. 1. Data frame support. Pandas provides data frame for tabular data processing. Page 20. 2. Data cleaning. Used for handling missing and duplicate data. 3. Data analysis. Supports statistical and analytical operations. 4. Data visualization support. Works with visualization libraries such as Matplotlib. 5. File handling. Supports CSV, Excel, JSON and SQL data sources. Functions of Pandas in data analysis. 1. Data preprocessing. 2. Data cleaning. 3. Statistical analysis. 4. Data visualization preparation. 5. Data transformation. Diagram, Spark SQL and Pandas. ++. Data analysis. ++. Backslash. Backslash. ++++. Spark SQL Pandas. ++++. SQL Python. Processing data analysis. 9 Quetzales. B. Determine and explain components and features of Spark architecture. Spark architecture. Apache Spark architecture is designed for fast and distributed data processing. It consists of different components that work together for efficient execution of big data applications. Components of Spark architecture. 1. HDFS. HDFS is the storage layer used to store large datasets in distributed form. 2. API. Spark provides APIs for Java, Scala, Python and R programming languages. Page 21. 3. Resource management. Resource Manager allocates CPU, memory and other resources for Spark applications. 4. Spark Driver. Driver program controls execution of Spark applications. 5. Cluster Manager. Cluster Manager manages resources across multiple nodes. 6. Worker nodes. Worker nodes execute tasks assigned by the driver. 7. Executors. Executors run tasks and store process data in memory. Features of Spark. 1. Fast processing. Spark performs in-memory computation for faster execution. 2. Distributed computing. Spark processes data across multiple nodes. 3. Fault tolerance. Spark can recover lost data using lineage mechanism. 4. Real-time processing. Spark supports streaming data processing. 5. Multiple language support. Supports Java, Python, Scala and R. 6. Machine learning support. Spark provides mlib library for machine learning tasks. Diagram, Spark architecture. Page 22. 10 Quetzales. A. Analyze different phases of text mining process with a diagram. Text mining. Text mining is the process of extracting useful information and patterns from large amounts of text data. Phases of text mining process. 1. Text preprocessing. Text preprocessing converts raw text into clean and usable format. Activities. Removing stop words. Tokenization. Stemming. Removing special characters. 2. Feature generation. Important words and terms are extracted from text documents. Example. Term frequency, TF. Bag of words, BO. Page 23. 3. Feature selection. Relevant features are selected for improving mining accuracy and reducing complexity. 4. Data mining. Data mining techniques are applied to discover patterns and relationships. Techniques. Classification. Clustering. Association. 5. Analyzing results. The final results are analyzed and interpreted for decision-making. Advantages of text mining. 1. Extracts useful information from documents. 2. Helps in sentiment analysis. 3. Improves business intelligence. 4. Supports decision-making. Diagram, phases of text mining. Page 24. 10 Quetzales. B. Identify and explain preprocessing steps and mining task for web content. Preprocessing of web content. Preprocessing is the process of converting raw web data into clean and useful format for mining. Steps in preprocessing. 1. Tokenization. Splitting text into small units called tokens or words. Example. Big Data Analytics. Big Data Analytics. 2. Data cleaning. Removing unwanted symbols, punctuation marks and noise from text. 3. Text tagging. Assigning grammatical tags such as noun, verb and adjective to words. 4. Stemming. Reducing words to their root form. Example. Playing, play. 5. Stop words removal. Removing commonly used words such as is, the, and. 6. Word frequency. Counting how many times a word appears in a document. 7. Term frequency. Calculating importance of terms based on occurrence in document. 8. Bag of words. Representing text data as collection of words without grammar. Page 25. Mining tasks for web content. 1. Classification. Grouping documents into predefined categories. Example: spam and non-spam emails. 2. Clustering. Grouping similar web documents together. 3. Association between web documents. Finding relationships between documents and web pages.